Contamination. Although lubricants are a relatively small part of operating and maintenance costs, they can have a significant impact on the direction of equipment reliability, longevity, and the overall maintenance budget. With a better understanding of the signs of contamination, you can identify potential problems early, saving you time and money by reducing both downtime and costs to repair and replace equipment. Why is cross-contamination of oils prevalent in industries today? The answer is obvious when considering the exponential growth in possible combinations of final, blended lubricants, growth in base oil types and additive combinations. The more lubricants you have to manage, the greater the risk of cross-contamination. However, remember, one small step. Over the years, many concepts of how to minimize cross-contamination issues in a lubrication program have been proven. Lean principles do help companies achieve sustainable improvements. In other words, small steps will avoid mistakes. Let's start by looking at the true meaning of contamination. According to ISO 14830, the meaning of contaminant is any foreign or unwanted substance that can have a negative effect on system operation, life or reliability. Types of contaminants. When thinking of contaminants, the first thing we think of are of course the solid particles. Particles coming from within the machine. They can be very damaging because they are very hard. Think of iron, from casting steel, bronze, many pumps use bronze, and aluminum. Maybe you wonder how contaminants achieve such large and drastic effects. Thing is, contaminants can be irregular in shape. They have sharp edges, which cause abrasion as they scrape metal surfaces, which in its turn, create additional contaminants.
Contaminants do not have smooth edges. They are irregular in shape and have sharp edges that cause abrasion as they scrape metal surfaces, creating additional contaminants. Let's follow contaminants in the hydraulic oil as it is drawn from the tank through the hose to the pump. You can see the contaminant's irregular shape with sharp edges and corners. Once the oil and contaminants are drawn into the rotating group of the pump, the contaminants can cause damage in several ways. The larger particles cannot pass through, but will break up as they strike the stationary port plate, shown here in yellow, and cause accelerated wear. Notice how the contaminants break down the edges of the port plate.
Not every contaminant is going to be as damaging as another one, since the material of the contaminant is very important. Less harmful, but still particles, are fibers from cleaning rags, rubber debris from seals and hoses, etc. Also important are of course the physical size, shape, form and the number of those solar particles. The larger they are, the more damage they can do. Liquids, such as fuel, water and even from incorrect lubes. Meaning when you add the wrong oil, with for instance the wrong viscosity, then that becomes a contaminant. Water is one of the most common contaminants. They can occur because of washdowns, condensation, poorly sealed reservoirs. Water increases the wear rate, and thus reduces bearing life. Air is not particularly damaging, but the air contains oxygen, and the oxygen can cause oxidation. So pulling the air out of the system increases the life of a system. So, how much contamination a system can tolerate depends a lot on the system itself, and some systems are going to be having much more need of cleanliness than others. It all comes down to the cleanliness involved in the components. One thing is for sure. All contaminants in the lube will affect the life of the components. Sources of contamination. A lot of contaminants can be introduced during the assembly process of a product, through pipes and tubes, hoses, welding, grinding, sanding, painting, etc., etc. Because those contaminants are very damaging, it's absolutely critical that we clear them out. Another place where we can get these contaminants from is during the filling of the system. Even, or especially, when the fluid is brand new out of a drum, it will usually be much dirtier than it will be for the rest of its life. So it's absolutely critical that we filter our oil before we put it in the system. The second most common issue is the environment, where the product is kept. The environment and the storage, where the product is kept, should be maintained in a way to reduce the contaminants. Without proper storage, filtration, and a plan to keep the environment clean, it is very difficult to keep the integrity of the product in line. A lot of contaminants are going to be created during operation. There will be abraded particles, purely from wear in the system. Contaminants lead to further contamination. Cleaning the systems once at the start is not enough. It's absolutely essential that these systems are cleaned continually for the life of the machine. This is one of the conditions to reach the necessary cleanliness levels. The fact that we can see through air does not mean that industrial air is clean. And with clean we mean the cleanliness we need for the system. Summarizing. Contaminants are introduced during manufacturing, during the use, and from the environment. What are the effects of oil contamination? The effects can be huge, both for the lubricant and machine. Let's take a closer look at the problems that contamination can cause with lubricants and machinery. As you can see from this table, some key properties of the lubricant can be altered when mixing incompatible lubricants. The severity can range from a slight reduction of the oil service life to catastrophic failures. For example, an air entrainment increase could cause the viscosity to rise, which can be the cause for the increase in temperature, which tends to increase the rate of oxidation. With cross-contamination of lubricants, all of the main functions of a lubricant can be negatively affected. Mixing two incompatible lubricants of the same viscosity can still cause the anti-wear or extreme pressure additives to be reduced to flock. If we increase oxidation rates, the sludge and varnish byproduct buildup will reduce the ability to transfer heat. A final warning. The most common cause of cross-contamination is the inadvertent application of opposing fluids. How severe the consequences of the contamination are depends on the amount of particles in the fluid, the shape, form of the solid particles, the flow velocity, the machine components and their sensitivity to contaminants, the material of the contaminant, the physical size of the solid particles, the machine duty cycle, and the pressure patterns in the machine cycle over time. Avoiding contamination. Contamination can be minimized, or even avoided through maintaining clean dry oil, adding breathers, adding oil sample ports to the equipment, and many more reasons. See for yourself. Also, lubricant manufacturers are taking steps to mitigate contamination in their products. Blending and handling processes through improved filtration between transfer steps have been improved. Many more examples will be discussed later on in this training program.